HEET is a nonprofit funded by foundations and donors. We do not accept funding from industry, whether gas or geothermal. Here are the next 5 years of gas infrastructure work sites, as reported by Massachusetts utilities. That's a lot. Over the next 2 decades, the total cost of this infrastructure will be greater than the cost of all the pipes in the ground now in their depreciated state. That's sort of crazy, especially when there's a regulatory docket that asks, how can gas possibly meet the state's net zero emissions mandate? HEET thinks that the NetGeo system might be the answer. It's a street segment network of ground source heat pumps. Like the gas system, the pipes are in the street with service loops going to each building. There are closed boreholes attached going down just a few hundred feet. The pipes are filled with plain ambient temperature water. Heat pumps in each building pull off the heating or cooling that building needs from the water. Gas utilities have the customers, the right-of-way in the street, and the financing methods to get this done. We had borough-happled engineering. The engineers for New York City's 80 by 50 plan create a Massachusetts feasibility study. They found the system with boreholes 500 feet deep, spaced every 20 feet down the street in the gas company's right-of-way, could meet 100% of the energy demand of most of our gas territory. In the dense part of cities, we'd have to add supplemental heat, make the boreholes deeper, interconnect the segments to pump the excess energy produced into the cities where it's needed. Networked heat pumps have advantages. Imagine an office building with the heat from its computers humming all the way through the winter. It's going to be rejecting heat into that shared loop of water, making the water hotter. That heat can then be used by homes down the street. Secondly, excess energy, for instance, heat in the middle of the summer, can be stored in the ground until it's needed months later in the winter. Colorado Mesa University has a system like this that serves over 1 million square feet of buildings. They're gas backup boilers intended to restore the temperature of the water in the loop if it ever gets too cold, have not had to fire for over 12 years. So what are the benefits? It's safer than gas. It provides cooling. According to the Applied Economics Clinic, it might even be cheaper too if financed by gas utilities in their normal way. And given our Massachusetts electric grid fuel mix, any building connected to the system would reduce its emissions about 60% in comparison to gas. As our electric grid moves to renewables, those emissions will continue to decline. Since the water pipe running up and down the street is the same type as gas, workers can easily retrain, keeping their benefits and wages. I'm excited to say regulators have approved Eversource to install a demonstration of the system in Framingham. It'll go in this fall. National Grid has 4 installations approved. With their installs, they will replace all gas appliances with electric ones. This is a gas utility performing electrification. Outside of Massachusetts, other installations are happening. So the first installation could go on the distal end of a system. There could be a single gas heater at the end of the street, providing supplemental backup heat if ever needed, which we know is not likely. Then additional street segments can be added and interconnected, backing the gas heater up further away, until gas is only needed at the very center of urban areas. In order to ensure we scale rapidly, HEET has a research team with Harvard, MIT, and 2 national labs. It will make the data transparent, analyze the results, and learn best practices. If we're successful, all of these potential fossil fuel installations could instead become seed sites for the NetGeo system to grow out from, moving all of us to safer, lower cost, more equitable energy. Thank you so much.